Hey, welcome everybody to our second to last Algebra 1 video here. So as you can see, I've officially entered the point of showering and then just getting right back to my pajamas. I think we've kind of all hit the end of that quarantine thing here. So the second to last video we're doing here, try to make it a little bit more interesting. This is actually something we would have done on like a half day activity, or maybe like a half day followed by a Friday activity if I could have made it planned that way for my classes. And it's just a way of letting us explore when the parabolas show up in other places. So this is going to be a strange little game that we're going to play. It's going to be called the jumping game. So what you want to write down here at the end, it's up to you how much you really want to write down. I would like you to actually attempt this. In order to attempt it, you're going to need 8 objects, 4 of one kind here and 4 of another kind here. I'm using these peppermint things and these quarters because I couldn't find anything else in my house. If we were actually playing this, we would have been doing it with, Reese's Pieces would have had like, 4, orange ones and maybe 4 brown ones, or maybe M&Ms or something, because that's what makes this most interesting. You can eat them afterwards. But I can't leave the house, or I'm not going to leave the house at least, and so I'm going to use these 4 and these 4. So if you want to participate and do the same exact thing with me, you can, and actually, do this like it would be a project in class. That would be wonderful, and you could play along and actually kind of learn something new. Or you can at least, watch and, write down a couple of things and, kind of at least play along or take guesses as we're doing it. So anyways, that's what you're going to need. To start this, you're going to begin by drawing a box close to the center of a piece of paper as you can around your largest object, whatever it is. So I'm just going to try to do it around just the circle part of it. So I'm going to go ahead and draw a box around it the best that I can, so you could see how beautiful my drawing is. And because I'm me, I'm going to switch the colors of the box as we go along, and we want to start with 3 boxes. So we're starting with 3 boxes here. Okay, so the game we're going to play is going to be very, very simple. There are a couple of rules to the game. So number 1 rule for this game, so we got rule number 1 is objects move in one direction only. So this guy over here, one direction only. You could imagine doing this when One Direction was popular. It's like, oh my god, One Direction. So awful. All right. So the objects move in one direction only. So this guy here can only go to the right, and this guy here can only go to the left. So our little peppermint guy only goes to the right. This guy only goes left. You are allowed 2 different types of move. Move option number 1 is a slide into an empty space. Option number 2 is a jump over opposite color. And I say color because, again, it would have been M&Ms. That was our original goal. So our 3 rules here: we can move one direction, slide an empty spot, or jump into an opposite color. And the goal of the game is to switch the positions completely. So switch completely. So for number 1, it's actually really, really easy. So our very first one, it's not going to take us very much effort at all. All we have to do, there's actually multiple different ways to do it, but we're going to slide that guy to the left. That's our sliding to the option. We're going to jump over here and then slide again. Okay, so let's watch it go one more time, what we just did. So we were starting, we're doing our peppermint guys on the left, our quarters on the right, and we started off by doing a slide here. That's one move, a jump, and then another slide over here. So let's go ahead and write down this pattern right off to start. So we did this very first one, and when we did, we're going to create a table, and we have a number of color and number of moves. And when we had one color, one of each color, I mean, that's what I'm trying to say, one of each color here, it took us a total of 1, 2, 3 moves to reach it to the end. And I messed up because this guy shouldn't have been right here in the way, because now I'm going to have to draw my boxes again. This was a silliness of me, so I'm going to have to draw my boxes one more time. So we got a box and a box, and I'm switching colors up here. But now we want to go ahead and increase the number of boxes to 5. So this is the part of class where I would stop, and I would be dividing you guys into groups, and I'd be saying, okay, I would like you guys now to tell me what to do if I had 2 of these here and 2 of these here. How many moves would it take to switch them up completely? Again, you can only move in one direction. You're only able to slide into an empty spot or jump over an opposite color. So if you actually want to attempt this and think about it, it's actually a little bit of a puzzle, and it will get harder and harder, in the next round when we increase to 3 or to 4. This is where you would pause the video and attempt it for yourself. So again, what you would actually need to do is draw little 5 boxes on your piece of paper here, and you would need to move around here to the best of your ability and see what you could actually accomplish. So I'm going to pause and see if you can get through it. One more time, the rules are one direction of movement. So these guys here can only move right. These guys here can only move left. You can slide into an empty spot, or you can jump over an opposite color. Please note there are ways to get stuck where you've quote-unquote lost and you need to attempt again. So pause the video, see if you can figure it out on your own, see if you got little objects you can jump with, or, be a little bit more lazy. I understand it's the end of the year here, and just watch me do it. So pause if you want. Okay, so here is one possible solution. So we could slide this guy here. That's one move, so we've made one move. Please note, if I moved here next, I got stuck, and you can't do that anymore. So that is not the correct move. So we made one move here. And then after that, we'd have to jump. So that was 2 moves so far. And then after that, we're going to have to slide. That is 3 moves so far. Okay. And now what do we have to do? Oh man, I'm forgetting how to do this. I haven't done so many years. That's what happens when you don't teach Algebra 1 for years. Forget the rules. So how many moves have I made? Okay, I gotta count again. This is embarrassing. It's okay, guys. So we gotta do, we got 1, 2, 3, let's see, 4, 5. Oh, that would be a stuck. I can't move anymore. That was not right. Oh, try again. See, I wonder how many times it would have taken you guys if you did this on your own. I have no idea. You can do it yourself. So we got 1, we got 2, we got 3, we got 4, we got 5, and I'm stuck again. Oh my gosh, this is not fun. What are we gonna do? How am I gonna figure out the correct option here? Try one more time. So we got 1, we got 2, we got 3, we got 4, we got 5, we got 6, we got 7, we got 8. Ah, we finally did it. It took us 8 moves. So we had 2 of the color. It took us 8 moves. I don't know if you guys tried that and how long it would have taken you to do it. Maybe you laughed at me while I was doing it and didn't even try it yourself. But now we're going to do the same exact thing. We're going to move it up to 3 total here. So we're going to add 3 of each color. So you're going to need to add to the number of boxes. So again, switching up the color. What is the number of boxes here? All right. I'm not going to have room for my last box. I'm going to have to imagine there's a box at the end here. All right. So, yet again, we can only move in one direction. You can only slide into any spot, jump over an opposite color. Again, I recommend trying it on your own, seeing if you're able to do it. Totally up to you. Hope the landscapers outside aren't too loud in the video. Otherwise, it's going to be a problem. Actually, I'm going to pause. There's a way for me to use a little sound thing. If it's silent for a second, except for the sound you want to remove, I can use a little audio program that I use to get that sound out. Anyways, so Let's try this out. Let's see if we can get this done. You can laugh at me as I mess up, or you can try it again on your own. So we're gonna go ahead, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. First try. Okay, much better on that second go. So we got a 3 and a 15. So we had 3 of this color. It took us 15 moves to get there. And now we want to do it with 4. So I don't really have enough room for my boxes at the end here, but I will at least pretend that there's room for the box there. Okay. So putting it there. All right, here we go. There's my 4th guy here and my 4th guy over here. And now let's go ahead and try it one more time. See if I get it on the first try again. That'd be most impressive. Not as impressive as number 2 though. It took me forever. All right, so we got 1, 2, 3, 4. I think I got stuck already. Yeah, I will get stuck if I do it this way. All right, not a first try. And again, you really should try this on your own. It's actually a little interesting. You should try to think and figure it out, and it might be something to use that time up on a good little boring quarantine day. All right, so we got 1, 2, 3. So I did last time. I'll get stuck again if I do it this way. All right, try again. All right. So we got 1, 2. How about 3, 4? This is going good. 5. What do we think? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so we got 24. Whew. Okay. So we finally actually finished this thing, at least this part of it. And now, again, if this was a regular class, we've probably spent a good 20 or 30 minutes doing this. It took us forever. There are probably some groups that figured it out right away, and other groups that gave up and started eating the Reese's Pieces, and then I had to hand out more of them. Done it a couple times. But now your job here is to figure out what is the pattern. What happens as I go from 1 color, it took us 3 moves, 2 colors took us 8 moves, 3 colors took us 15 moves, and 4 colors took us 24 moves. So without doing the 5, because they don't even have 5, and it would take a very long time to actually do the 5, and you might mess up a few times, kind of like I was doing there. Figure out what would be the number here that 5 goes. So, if you want to try to think about it, this is called pattern recognition, and it's a very good way of learning math and practicing math. And as you notice, it's really different than what we've been doing, but it's very good for your head to do stuff like this. I'm going to pause the video. I'm going to let you try to think about it. And really, this is the most important part in a lot of ways of the lesson in terms of real learning here. So there it is. Pause. See if you can figure it out. How do you go from 3 to 8 to 15 to 24? So we're going from 3 to 8 to 15 to 24. All right, so there you go. We've tried it out for just a moment, and if you notice, we went up by 5 on this problem. But then we went up by 7 on that one. And then afterwards, we went up by 9. So this one, if we were to add a 5th one at the end, and you could really spend the time doing it if you really wanted to, it would take a total of 35 moves to get there. This is a little bit tough to do, the next step here. So I'm actually giving the same exact video to both Algebra 1 and Algebra 2 because it's a cute little thing just to work with that ends up going through. So typically when I do this, I do it with both Algebra 1 and Algebra 2 students. Algebra 2 students, I just say, nope, you get to go by yourself and you have to figure it out. Good luck. You can spend, a good 20 minutes doing it, but it is a pattern that we've done so far this year. And Algebra 1 students, I give them a little bit more of a hint. So if you're an Algebra 2 student, I recommend just going for it, see if you can figure out the equation. Because what I want to do is I want to create an equation where I say f of n equals, where if I plug in n, where is the n is that number of color over here. So this is my n, and I want to end up at m. So f of n equals m, or f of n equals, and I want an equation that gives me the number of moves that are correct. That is, if I plug in 1, I get 3. So that means that if I make n equal to 1, I end up getting 3. If I make n equal to 2, I end up getting 8, so on and so forth. So what is that equation that goes here? If you're in Algebra 1, I have one extra hint for you to start with. The extra hint was, if I were to go backwards here, this is plus 5. This one right here must have been a plus 3. Or in other words, this guy had to be 0. So it must start off at the origin, or 0, 0. That is to say, I could add an extra part to this column here, a 0 and a 0. Furthermore, I give us another hint and say, hey, what have we been doing for the last couple of weeks? What I mentioned at the start of the video, it has to be a parabola of some kind. So it's a parabola of some kind where, if we remember our parabola equation from earlier, that would be ax squared plus bx plus c. And c right here is that 0, 0 coordinate. Because it comes from there, c must be equal to 0. You can think about it just a little bit more on your own here, what that equation's going to be. So maybe just a little bit of guess and check would be good for you, just so you could see how you could figure this out on your own if you really, really wanted to. So we know the very first time I'm jumping up 3. So for instance, if I tried to make a equal to 1 and b equal to 1, let's just try it, see what happens. If I were to do that, well, what's going to occur is I would have 1 multiplied by plugging in 1 here. 1 squared plus 1 times 1, that's 1 plus 1, that's 2. That's not going to work out for me. So let's just go ahead, I'm going to move on to a separate sheet of paper here. I'm going to need that piece of paper for later, so don't totally get rid of it if you're still doing it. So again, my numbers I was doing were, I had 0, 0 as one of my coordinates. I had 1, I already forgot, I gotta look at it. 1, 3. We had 2, 8. We had 3. We added 5. We're adding 7. We had 4, we added 7, and then now we had to add 9, so we had 4, 24. Okay. We know that we have to look like a parabola. And because of that very first coordinate, we know that c has to be equal to 0. Okay, so we have that. But now we need to figure out the rest. So I have 1, 3, 2, 8, 3, 5, 4, 24. So we tried out a equals to 1, b equals to 1, and it didn't work out. So what we should do is, we know it has to equal 3, so either a equals 2 or b equals 2. Let's just try a equal to 2. So we have y equals, we're going to try 2 times, and we usually should be n because I used n earlier, but I'm just going to switch to x because I don't feel like doing anything else. So we have 2x squared plus, 1 x. So I am attempting a equals 2 and a b equals 1. We're going to see if it works. So if I make a equal to 2 times 1 squared plus 1 times 1, I get y equals 2 plus 1, y equals 3. Okay, so we have y equal 3. That worked. That's this guy right here. So when I made x equal to 1, I got 3. So that's that's good. However, it would have worked also if I did a 1 here and a 2 here. But now we have to check the second one. So let's check the second one. So we have y equals, we got 2 multiplied by 2 squared plus 1 times 2. That's y equals to 2 times 4 plus 2. Y equals to 8 plus 2. Y equal to 10. Oh, that's no good. That is not what this is. This is not right. So therefore, a equals to 2, b equals to 1 does not work. Now, we did say the other way would work out, so let's see if it would work out. Let's try instead a equals to 1, b equals to 2. So that's going to be the equation y equals 1x squared plus 2x. Remember, you actually don't need that 1 there. It's invisible, so we don't have to write it if we don't want to. Anyways, so we're going to go y equal to, I'm not going to write the 1 there anymore, but we're going to see if it gets the first coordinate. 1 squared plus 2 times 1. That's going to be 1 plus 2. That is 3. So my first coordinate works out. That's good to go. We're happy hunky-dory for this guy. Now we got to see if we get the 2, 8. So we have y equals to 2 squared plus 2 times 2, and that's y equals to 4 plus 4. That's y equals to 8. Great, we got that one. So we have the 2 and the 8. One more try at this. Let's go for it. So we got y equal to, let's plug in the 3 and see what happens. So again, we're plugging it into this equation right here. We got 3 squared. I'm not writing the 1. It's invisible. It's not needed. 2 times 3, and that's going to be y equal to 9 plus 6. That's y equal to 15. Sure enough, I get my 3, 15, and I have found my equation right here. 1x squared plus 2x. So let's look at the game one more time, going back over here, because we have found the equation for our guy. We have found f of n equals, and we have now gotten to n squared plus 2n. Okay. And now, most likely, we're probably bored in class again, and I say, well, I hope you guys remember the solution to the game, because I'm going to make you try it one more time. You need to play this game one more time, going all the way back to the start, and we need to do a little bit different. Because I want you to go back again. And now I don't want you to record the number of moves. I want you to record both different types of moves as you go on. So this time, you're actually going to create a 3-way column where you still have the first one as your n, your number of your color. And in this case, I will have a 0 column, but we're not going to be able to fill it in yet. We got 1, we got 2, we got 3, we got 4. I think it's going to be good enough. But now I'm going to have 2 new letters. I'm going to introduce the letters S and the letter J. The reason why is, going back to the original rules, you can only slide S or jump. And in every single one of these games here, even though the number of moves was 3, the number of slides and jumps, obviously, or maybe not obviously, but they are not going to be the same. So we need to count and figure out for each one. So it's going back down over here. So how many moves are they going to do to switch the positions? We got 1 slide, 1 jump, 2 slides. So here we had 2 slides, 1 jump. And by the way, for 0, it's 0. Okay. Number 2. Again, if you want to retry this for yourself, see if you remember the solution, that's okay. I might have already forgotten the solution myself to winning this game here. So we got slide. Let's write it out. Let's write this out. So we have slide for the first move, jump, J, and then we had another slide, and then we had a jump and a jump, 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 and then we had a slide, a jump, and then a slide. Okay, so we have written out that one. It was slide, jump, slide, jump, jump, slide, jump, slide. Whew. Tongue twister almost. So how many moves of each kind? So we had 1, 2, 3, 4 slides and 1, 2, 3, 4 jumps. Ooh, so these ones were exactly the same. But if you notice, my slide went up by 2 and my jump went up by 3. So it's different. So if that pattern were to like continue in some way, we need to figure out the number of slides here. Probably, oh, by the way, the very first one, if I'd done it, would have been slide, jump, slide. This one over here, the number of jumps, if it goes up by 1 and then up by 3, I'm imagining, going back to that first pattern, went up by 3, then 5, then 7, then 9, then 11. This one's probably going up by 1, and then by 3, and then by 5. I'm going to guess the number of jumps here is 9, and this makes it a 6. Before we actually show that this is true and this works out, let's go back for just a moment to this page so we can have a little bit of big brain moment and have, ooh, where did this come from? If you notice, there's that 9 and the 6. There's the 4 and the 4. There's the 1 and the 2. These x squareds and x's represent the slides and the jumps, respectively. Let's actually figure it out. Let's make sure that we're not just making things up, that this is actually a true statement. Okay. Excuse me. Okay, so here we go. All we got to do, we have a movement. We have a slide once. Okay, so let's start writing out the solution here. So we have a slide, and then a jump. And then we got another slide. And then we got a jump and a jump. And then we got another slide. We got, oof, did I mess up already? I think I messed up. Right, because I can't jump over here. I could jump there. I would mess up. Oh, no. No. I already messed up, guys. This is so sad. Try again. I wish like someone was here to tell me what I'm supposed to do right. Again, you should be trying this on your own, too. Recording this. We got 1, 2... Okay, that was a slide, jump, slide, and then jump, jump was wrong. Try again, one more time, sorry. So we had slide, jump, slide. Maybe that's not right. Let's try this again. I'm sorry, guys. We have a slide, we have a jump, we have a slide. So we had slide, jump, slide, and then we have a jump. Yes, and this was right. And then another jump, and then there is another slide. You just don't go that way, you go this way. Okay. Then we have another slide, and then we have jump, 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 jump. Oh. Man, so much easier to use these PCs. So then we have jump, jump, jump. And then we have, what do we got? We got slide. We got jump, jump. We got slide. We got a jump and a slide. Whew! All right, so it took us long enough. What did we actually get down? We got slide, jump, jump, jump. Did we actually get what we expected? Did we get 6 slides? We got 1, 2, 3, 4, 5, 6 slides, sure enough, and 1, 2, 3, 4, 5, 6, 7, 8, 9 jumps, as we expected. So we're not going to do it with the 4. If you really want to do it with the 4th one, you can, but we'd be adding 5, adding 7 here, 16, adding another one, 8, and again, if we went back and tried it on the formula form, if I were to plug in 4 here, f of 4 equals 4 squared plus 2 times 4. We get 16 here and 8 here, where again, this guy right here, the n squared, that is representing the number of jumps in the problem, and the 2n is representing the number of slides. And this actually continues off forever. If I were to expand this game and go off to 5 boxes at the end, the 5th row, the same exact thing would happen. I would add 2 here to get 10 total slides, and if I had a 9 here, I had 11, I'd have 25 total 25 total jumps. Anyways, this would have been, again, a good half day. This took 30 minutes for me to do right now. It'll take us a little bit longer, 45 minutes to an hour, in class. So it's a great half day activity. Unfortunately, we didn't get to try it out, but I don't know. If you had me in Algebra 1, maybe we'll try it again on 11th grade, because I'm most likely teaching Algebra 2 next year as well. So anyways, hopefully that was interesting. Second to last little lesson there. All I need from you as proof is some version of what you wrote down. Maybe you wrote down the boxes. Maybe you wrote down you wrote down a table or something. Or I don't know. Maybe you can just say, hey, Mr. Richards, I watched this video, and that'll be enough proof for me. Have a great rest of your day, and I'll be recording one more video for each class after this one. Have a good one.